Yes, sir.
Better. Welcome to all. Camera leaving. Welcome. I will be taking the structure engineering part. See, I'll start now. See, in the syllabus it is given. We just given elastic constants. Elastic constants. Little later, you will be knowing elastic constants are E, comma, G, comma, not E, only. Elastic constants. They are actually E, mu, then G and K. This E is called Young's modulus of elasticity. Young's modulus of elasticity. Not use this word, so if you overlap it, or you don't have to waste time. If the calling Young's modulus of elasticity, or simply called the modulus of elasticity. Modulus of elasticity. Or sometimes called elastic modulus. Elastic modulus. All are same. Universal symbol is E. Okay, now mu is Poisson's ratio. Poisson's ratio. Then G stands for modulus of rigidity. Modulus of rigidity. Or sometimes called shear modulus. Shear modulus. K is called bulk modulus. Bulk modulus. Okay, now our symbol is G. Some places for G, they use symbol C. C. Or rarely N. See, I told you some places C. Or very rarely N. But we will always take G only. We will always take G. Because if I see the printed matter there, one question given there, it is given E equal to 2N. So they wrote E equal to 2N. So you should know that one. If they write E equal to 2N, they are telling E equal to 2G into something, into 1 plus mu. Okay, leave it. These are the 4 elastic constants. Now, usually syllabus, they used to write stresses, strains, strain energy, deformation, then what you call strain energy stored, members of tapering section, compound bars, so many things they will write there. Then they will write elastic constants, etc. But SSC-JE, they simply told elastic constants. But remember, just because they told only elastic constants, I cannot just take E, G, E mu, GK and start. Because in the question paper I have seen there, they ask questions connected with E, connected with mu, G and K. Therefore, do one thing. Syllabus point of view, this one. Okay, now, little elaborate we start. Now, Start fresh. Fresh. Do not see anything here. Right here. Do not see anything this side. Don't see this side. First consider. See, I start now. Consider a member. See, in this class, we cannot tell too much of story and tell. Then story, if I tell so many things, it will take hours together. Briefly or solve. So, consider a member of length L. Remember, L is also called as initial length. Remember, when you tell length L, it actually means initial length. Some people call original length. Both are same. Original length. Some people call original length. So consider a member of length L means understood that length L is initial length or original length. Then let capital A be cross-sectional area. Cross-sectional area. See, I will explain one by one. Then let A be cross-sectional area. Next, let P be axial force. Axial force. See, axial force can be either tensile. It can be either tensile, means producing tension, or it can be compressive. It can be either tensile or compressive. I will discuss it. P, that is axial force. Then A is cross-sectional area. Okay, now leave it. See, what I wrote now, you should write. I am removing the board now. Everything I am removing. Push ಮಾಡಕ್ಕಾಗತ್ತಲ್ಲ ಹಿಂದಿನ ಪೇಜ್ಗೆ ಬೇಡ ಅನ್ಸುತ್ತೆ ಏನ್ ಮಾಡ್ಬೇಕಿಲ್ಲಿ ನೆಕ್ಸ್ಟ್ I am new to this board. That's why problem. Okay, now do one thing. You sorry. ಈಗ ನಾನು ಇದೇ ಸರ ಕೊಟ್ರೆ ಹಳೆದು ಹೊರಟೋಗುತ್ತಾ ಇರೇಸರ್ ಕೊಟ್ರೆ ಹಳೆದೀಗ ಹಿಂದೆ ಇರೋದು ನಾನು ಇರೇಸರ್ ಕೊಟ್ರೆ ಹಿಂದೆ ಆಗಿರೋದು ಆಗ ಬರ್ದಿರೋದು ಹೋಯ್ತು ಅದು ಹೋಯ್ತಾ I want red color. Study this way. You take a member here. See, correct one case. Or I will write here. Or another case here. I will dictate everything now. You should write. This is your member. See, this is, I use red color. This is your length L. Length L. Here, this is length L. Length L. Then, see here, member is like this, length. Cross-section means always you have to cut it. When you cut, you are seeing cross-section. See. So, I show a small cut here. And I will write A means cross-sectional area over. You cannot see it here. A. I will write one thing here also. Show a cut here. A. This is A, you write A means what? Cross-sectional area is A. Now, I told just now, subjected to axial force. Axial force means you have to apply from both sides, opposite direction. See here. It can be, see my hand, tension. See? If you take something here, any object for that matter, I will take a pen here. Here, I will hold in the hands and pull outwards. It is called tension. Or push inwards. It is called compression. So, tension means here, this way. P. If that is P, this is also P. This is the case of member in tension. Member in tension. Or come here. See, apply a force like this, P. Here also apply a force this way, P. This is case of member in compression. Member in compression. See, writing may not be fully clear. I am dictating. My voice will be clear for you. See, this is member in tension. That is member in compression. Then, see here. If member is in tension or compression, irrespective of that way, I will put common here. See, common for both. I will do one thing now. The common for both. Let sigma be axial stress. Axial stress. Or it is also called as normal stress. Normal stress. Because it is normal to cross section. Normal means perpendicular to cross section. See, sigma. See here. This way we apply, stress will come. Sigma equal to, sigma is always equal to force divided by area. Axial force. Not force. Axial force by area. This is common for both. Whether tension or compression, common for both. Okay, now, further. Also let delta, I use delta be change in length. Change in length. Now you make a note here. I will dictate. You should make a note. I will dictate here. If member is in tension, member will elongate or extend. Length will increase. Whereas if member is in compression, this way, length will reduce, or it will get shortened, or it will get contracted. I am telling only once, remember, if anything is not clear, I cannot every class repeat the things. What you have to do, go through recording repeatedly and understand. So now delta is generally called change in length. So now do one thing, come to this case. If you come to this case, this is common for both. Here, delta will be what? I am discussing the case of what? Member in tension. Delta will be increase in length. Increase in length. Whereas, see here, if I come to this case here, delta will be decrease in length. Decrease in length. Now, be careful. Change in length is general. See, whether increase or decrease, general term is change. Here the change is increase, there the change is decrease. I already explained to you. Now, instead of increase in length, some people call elongation. Both are same meaning. Elongation. That is delta. Some people call delta as elongation or extension. All same meaning. Extension. Here, in decrease in length, some people call contraction. Contraction. Therein are shortening. Shortening. I am dictating. Here, increase in generally it is called delta. It can be increase or decrease depending on whether member is in tension or compression. But when you come to see, that is what I wrote here is general for both. See, this is common for both. Now come to only this case. Member in tension. Delta is called increase in length or elongation or extension. There delta is called decrease in length or contraction or shortening. Okay. Now, again common for both. Again common for both. This way. Common for both. Common for both. A term called strain will come. Strain. Symbol is epsilon. See, epsilon. Make a note. Little later, you get one term called E. E is different. Epsilon is different. E is different. Epsilon is different. E is, already I told you, modulus of elasticity. Epsilon is strain. Strain is epsilon. The strain is, see, strain, or some people call axial strain. Axial strain. Both are same. Or some people call linear strain, lengthwise. Linear strain means lengthwise. Remember, lengthwise, because change in length accordingly. The strain is ratio of, you should write here, no space to write. I am dictating, you should write. You should write earlier. Stress is the force per unit area. Then write. I forgot right here. Therefore, see, I forgot here, right? Sigma equal to P by A. I forgot right there. Earlier, common data. Sigma equal to P by A. Hey, same way. Right. Strain is the ratio of change in length to original length. You should write. There is no place to write here. So write strain in general. Common for both. Irrespective of tension or compression, strain is called ratio of change in length to original length. Therefore, strain equal to delta divided by L. Remember, strain is always unitless. Delta divided by L. This you write strain. Then, I will continue further. Now write here. Now one small note you write here. I will dictate here. I will dictate here. You write. So, if the member is in tension, the strain is called tense. Stress is called tensile stress. Strain is called tensile strain. If member is in compression, stress is called compressive stress. Strain is called compressive strain. After the class, you should write it. After going through the class, make note of that one. Okay. Now, this full board I will remove. I will go backwards. Okay. Over. See now. We have Hooke's law. Hooke's law. Before that, some statement I am telling. Some statement I am telling. I will sit and dictate. You should write it. I will sit and dictate. You should write it. See, these all you should write. When you apply loading axial force for a member, member length will change. If it is tensile force, length will elongate or increase in length. If force is compressive, length will decrease or shortening of the length. Voice clear? Clear? Okay. Now, by chance, if you remove the load, initially, the moment you remove the load, member will regain its original position. Whatever increase or decrease which has taken place will vanish. So, when the external force is removed, the member will jump back to its original position. this property of a material by virtue of which it will regain its original position after the removal of external axial forces is called elasticity. Is called elasticity. Once again, I am telling, on the board I am not writing. If you are serious, you should write all these. Property of a material by virtue of which it will regain or spring back to its original position when external axial forces are removed. But make a note, there is a limit for it. Limit. That is called elastic limit. So this member regaining its original position when external forces are removed is only up to elastic limit. But if a member is stressed beyond elastic limit, it will not regain its original position. Little strain will be still left in the member, means little deformation is still left. That is, when deformation is left in the member, it means what? Some strain is still left in the member. It will not come back to original position if you stress the member beyond elastic limit. That strain which is left in the member even after the load is removed is called permanent set. Permanent set. Objective question can come. The strain left in the material after the external forces are removed is called something they will tell residual stress, permanent stress, something they will tell permanent set. Okay. Now, I will come back here. In strength of materials, we always consider behavior within elastic limit. We never consider behavior beyond elastic limit, except for stress strain curve. Some stress strain curves are there. That is theory. Only for the theory, for stress strain curve, we will discuss up to failure. Otherwise, in strength of materials, in structures, in RCC only we taught RCC. In strength of materials, later structures, complete subject, we will always consider within elastic limit. Okay. Now, I told elastic limit. Now, it is observed that the intensity of stress, that is sigma, or simply stress, simply called stress. What stress? Axial stress. Axial stress. I already told you sigma equal to P by A. Okay, I told already. The intensity of stress is proportional to strain. Proportional to strain. Strain is epsilon. Epsilon equal to, I told you, delta by L. This I already told. Intensity of stress or stress is proportional to strain up to proportionality limit. Proportionality limit. That means a question will come. What is proportionality limit? Answer. It is the limiting limit up to which stress is proportional to strain. Okay, now most of the metals we are using properties that elastic limit, and you make a note here, elastic limit or proportionality limit, both are very, very nearby. See, it is very nearby. Suppose you draw a curve here, for example, straight line. This is proportional limit. Somewhere here, oh, they are very, very near. Or in maximum questions, We don't bother about that one. But technically, remember, property of a material by virtue of which it will spring back to original position is called elasticity. That is valid up to elastic limit. Whereas stress proportional to strain is up to proportionality limit. This statement is called Hooke's law. It is Hooke's law. Hooke's law. Hooke's law statement is what? Stress is proportional to strain up to limit of proportionality. But 99% cases, people tell up to elastic limit. So unless a data is given, if it is not mentioned, it is understood that elastic limit and proportionality limit both are same. Both are same. Okay. Now, so now onwards, I will not use the word proportionality limit. I will tell elastic limit. Okay. This is Hooke's law. Now see, therefore, 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 stress is proportional to strain. Epsilon. See, stress is proportional to strain. Stress equal to what? Stress equal to P by A. Strain epsilon equal to delta by L. Therefore, what? 1 minute before that, I remove that one. I remove that one. Stress is proportional to strain. See that one. Right. Or see, you know mathematics. When something is proportional to something, there's a term called constant of proportionality, or stress equal to a constant of proportionality, constant of proportionality into strain epsilon. This constant of proportionality, that is, when stress is proportional to strain, there is a constant here. That is material property. It is property of a material. It is a material property. It is a material property, and it is called Young's modulus of elasticity. Young's modulus of elasticity. Or I already told you, technically called Young's modulus of elasticity. Technically called Young's modulus of elasticity, but people are lazy. Nobody want to tell Young's modulus of elasticity. See, shortcut. So therefore, it is called modulus of elasticity. Some people call elastic modulus. Our symbol is E. E. Young's modulus, capital E. Okay. Now, I remove this one now. Eraser. This I will remove. ದೊಡ್ಡದು ಮಾಡೋದಂಗೆ ಇರೇಸ್ ಮಾಡಕ್ಕೆ ಇಷ್ಟೇನಾ? Okay, no, I will remove clean. I will clean it. Start. I told just now, stress. Okay, I use black, white color. Stress proportional to strain, or stress equal to what? Modulus of elasticity into strain. Therefore, remember, this is the basic equation. This is the basic. See, underline it. This is the basic. Stress equal to Young's modulus into strain. Or if you want E from here, E equal to here stress divided by strain. This also same answer. Stress divided by strain. Or if you want strain, epsilon equal to stress divided by Young's modulus. Stress divided by Young's modulus. Now, be very careful. What happens is, I will not repeat. See, I will not repeat again and again. I decided. Sometimes what I do is, I tell same thing again and again. No, recording is there. If doubt is there, go through again and again. Okay, now, see, stress equal to, I will tell you here. See, stress equal to Young's modulus into strain, or Young's modulus equal to what? Stress divided by strain, or strain equal to stress divided by Young's modulus. Sometimes people get confusion, not me. Don't tell me. I will not get confusion for this one. You will get, right? You will get confusion, not me. Don't include me. For that, best option I will tell you, remove the board, the cleaned board. Best option is, remember one thing. Remember. This is what 99% people remember. Remember, people want this way. See, stress divided by strain. Commuter, sir, got it, sir. I think you know all of Kannada. See, since this is outside the Kannada. Okay. So, Kannadalli, sir, idu gottu sir antare. Gotta? Sari aaytu bidi. So, stress divided by strain is Young's modulus E. What shall I say? Equal to modulus of elasticity. That is mathematically stress divided by strain equal to E. Remember this over. Now somebody will ask, no, I want stress equal to. You tell, hey, what is there? See here. Therefore, if somebody wants, if you want, or if somebody wants, equal to, you tell, oh, no problem. Strain into Young's modulus. Or if somebody wants, no, I want strain. Okay, strain, go that side. Come here. Strain equal to stress divided by Young's modulus. Over. Now, I will give warning to you. I give in my class, I am very famous for giving warning song. Warning for those who are not serious. Those who are serious, they don't require warning. They require advice. So it is advice come warning. Study everything correctly, make a note, understand. There is no difficulty. Repeatedly go through whenever you get doubt. That is advice. Warning. Don't study properly, irregularly come to the class, suddenly come to a class and tell nothing clear. Nothing will be clear for you. How everything can be clear for you? My voice will raise then. How it can be clear? You are not studying properly, not attending, simply coming to a class and asking. Like you go to a movie, suddenly ask, who is he? They will tell, why you came late? That way. Not valid. So now I will tell, sitting here, you remember one thing. Stress divided by strain equal to Young's modulus. That's all. See there, big I wrote. Sigma stress by epsilon strain equal to Young's modulus E. Remember this one, you get these two very easily. Now onwards, remember, I will not waste time. I will give a numerical now. Okay. Now, question 1. Now only. Question 1. Usually when people are there in the offline class in front of me, I will tell them, solve now. Okay. If stress is 2, not 2, if stress is 50 Newton per mm square and strain is calculate. Strain is 0.0025. See, remember one thing. See, stress is Young's modulus into strain. Strain is unitless. And stress is what? P by A. So, stress unit will be what? Force by area. Newton per mm square or Newton per meter square or kilonewton per mm square or kilonewton per meter square. Most popular is Newton per mm square. It is force per unit area, unitless. So E will have, see, this is unitless. E will have same unit as stress. So remember now, stress sigma and modulus of elasticity E both are force by linear square. Force by linear square. Remember that one. Little later, I will explain once again. Okay. Now, question is this way. Find or not find. They will ask you what? What is modulus of elasticity? Modulus of elasticity is the question. Objective question. One mass question. See. How to solve? Remember, SSC-JE calculator is not allowed. First paper andre idikilwa I have to 1 minute now. He is telling for prelims calculate is not allowed, and then ಅದೇ ಯಾವಾಗ ಬರುತ್ತೆ ಮೈನ್ಸ್ ಅದೇ ನಾವೀಗ ಮಾಡ್ತಾ ಇರೋದು ಯಾರಿಗೆ ಎರಡಕ್ಕೆ ಮಾಡ್ತಾ ಇದೀವಿ ನಾವು okay. Therefore, I will 1 minute now. See, these are not, see what I am confusion now is, this is not subject confusion, not structural confusion. This is your problem for calculator allowed or not allowed. So today, I will imagine this question is preliminary, prelims. Calculator allowed illalla? No calculator. Okay. Imagine calculator is not allowed today. When I take next class, I will go for clarification. I will ask where allowed, where not allowed. I don't know. See, this is not in my hand. Whether calculator allowed or not allowed is your problem. Or if calculator is not allowed, they should give the question so that you can solve without calculator. Or if calculator is allowed, they can give random questions. Okay. What is elastic modulus? See here. Imagine today calculator is not allowed. You imagine Calculator not allowed. Start. Solution. Stress is 50 right here. Stress equal to 50 Newton per mm square. Okay. Then strain epsilon equal to 0.0025. No unit. They want what is E. Question is what is E? How to solve? You know that E equal to, see now, I just now told you, stress. Yeah, E equal to directly stress divided by strain. Stress divided by strain equal to stress 50 divided by 0.0025 or see 1, 2, 3, 4, 50 or equal to 50 divided by how much it is? 0.0025 is here. 0.0025 is there. What you do? You make 10, 100, 1000, 10,000. Multiply both by 10,000. This will become 25. This will become 25. 25 2 times or 10,000 correct? 1 minute. Let me see. Oh, sorry. It is 0.0025. Oh, okay. 0.00 right. ಯಾಕೆ ಬರಿತಾ ಇಲ್ಲ ರೈಟ್ ಬರಿತಾ ಇಲ್ಲ ನಾಟ್ ರೈಟಿಂಗ್ ಇದು ಹೇಗಾಗುತ್ತೆ ನೋಡಿ 0.25. See, without calculator, what to do is see 50 divided by what? 10, 100, 1000, 10,000, 1 lakh, 25. Then you multiply both by 1 lakh. So 50 into 10 to the power 5. 50 by 25 is 2. Your answer is E equal to 2 into 10 to the power 5 Newton per mm square is the answer. Ten to the power 5. This is the answer, Newton per mm square. Therefore, for this question, your answer is how much? Your answer is Young's modulus E equal to 2 into 10 to the power 5. 10 to the power 5 Newton per mm square. Or suppose they give the answer in kilonewton per mm square. Answer is 2 into 10 to the power 5 Newton to kilonewton multiplied by 10 to the power minus 3 kilonewton per mm square. Or it will be 10 to the power 5, 10 to the power 2, 200 kilonewton per mm square. See, you got the answer without calculator. Why? Because numbers are given so that you can calculate. Okay, now next question. Second question. It is found that they will tell stress is 200. Stress is 125 Newton per mm square. There is a term called MPa, GPa that I will tell in the next class, not today. Next class. Okay. Stress given. And they will tell Young's modulus of elasticity E equal to 130 Newton per mm square. 130 10 to the power required. 130 10 to the power 5 Newton per mm square. Some material. They are asking you what is the strain. what is strain? Or I will do one thing now. Instead of 125, I will go for some other number. Stress is one stress equal to 168 Newton per mm square. What is the strain? Question. See now. Start. You know that stress divided by strain equal to Young's modulus, or your strain equal to stress divided by Young's modulus equal to stress. 168 is the stress divided by Young's modulus is 130 10 to the power 5. Now 168 by 130, how to calculate? Not required. They will give options. Nodi. Option A, option B, option C, option D. Calculate. Option is C. Option A, B, C, D are there. Option is .02 to 10 to the power minus 3, 0.013 10 to the power minus 3, 0.008 10 to the power minus 3, and last one is 0.14 10 to the power minus 3 is the option. See now, correctly observe. If calculator is there, no problem. See what you do. 168 divided by 130 10 to the power 5, it will tell the answer. But if calculator is not there, see here. 168 by 130. What is the answer? See, 168 by 130 surely. See, 168 by 130. It is more than 1. How much? It is more than 1, but less than 2. Therefore, this is gone. This is gone. Oh, among these two, one of the answer. Among these two, one of the answer. Why? More than 1, less than 2. Why? 0.13 is there, 0.14 is there. Now, what you do is, see, go further. 168 10 to the power 5. But they told answer in terms of 10 to the power minus 3. What you do? Or 168. 168 by what? 130 into, see, 1 by 10 square into 1 by 10 cube. Okay. This 10 cube is what? 10 to the power minus 3. Or it is 168 divided by what? 130. See, 13000. Now do one thing. Calculate. 13 ones are 13. How much remains? 3 remains. 13 threes are 39. Almost 3. Oh, this answer. See, this answer. What you do is use your brain and decide which is the correct answer. If calculate is not given. Anyway, today is a starting class. As we go further, when I solve question where calculate is not there, I will very clearly explain. Don't worry. I will very, very clearly explain to you. Okay. Now, clean. Last question. Last question. What stress will produce a strain of 0.2 into 10 to the power minus 3 if E equal to, this is a question. What stress will produce a strain of 0.2 10 to the power minus 3? Then in the question given, E equal to, see, what stress will produce what? A strain of 0.2 10 to the power minus 3. In the question given, E equal to 200 10 to the power 2 10 to the power 5. It is given 2 10 to the power 5 Newton per mm square given in the question. Okay. Options I will give later. How to solve? See, stress divided by strain equal to Young's modulus. They want stress. So stress equal to what? Strain into Young's modulus. Strain is 0.2 into 10 to the power minus 3 into Young's modulus is 2 into 10 to the power 5, or 0.2 into 2 is 0.4. 0.4 into 10 to the power minus 3 into 10 to the power 5 is 10 to the power 2, or 10 to the power 2 is what? 100. The 100 into 0.4, 100 into 0.4 will give 40 Newton per mm square. Okay. I am also not used for this. Yes, 40. Oh, now you got the answer. Actually, remember, option A, option B, option C, option D. What they will do is they will give 4, 40, 400, 4,000. Because they know, everybody knows here. See, for 2 2s are 4. Starting number should be 4. That everybody knows. Suppose they give the answer 30, 40, 50, 60. Undoubtedly, 2 2s are 4, 40. You don't have to calculate. So what they will do? All given. So you should calculate this way 40. Here, take the answer. Okay, this is application for elastic modulus, one of the elastic constants. See, I told you elastic constants are E, mu, G, and K. I told about E today and some basic part for you. You study all these. Next time, I will go for more rigorous calculation. I will, by that time, I will confirm where calculate allowed, where calculate not allowed. Okay. We will see the next class. Thank you.